Yeah, good afternoon, friends. Today I will discuss about how to implement stack and linked list. Your stack and linked list both are main important topics of your data structure and algorithm. Your data structure and algorithm paper will not complete without stack and your linked list. Before starting the implementation of stack and linked list, all our should know about what is stack and what is linked list. You know, stack and linked list, as per I had told, both are main important topics. And now I am sharing my PPT. I hope you can see my PPT. As per I had told, today I will discuss about how to implement stack and linked list. In this lecture, I will cover so many topics of your stack and linked list. Mainly, I will cover how to implement the stack and linked list. Object and outcome of stack and your linked list. What is stack and linked list? Operations of stack, algorithm of stack and linked list, implementation of stack and implementation of your linked list. I will discuss about the stack and linked list because if you know about the stack, like what is stack, why stack is necessary, what are the operations of your stack, how to implement the stack, how to represent the stack, how to implement the stack operation, and also if you know about the linked list, what is linked list, what is node. Okay, that's why I am giving the overview of stack and linked list before start the implementation of your stack and your linked list. Okay, object and outcome of your linked list and your stack. If you will stack to convert expression from infix to postfix, and if you will use the linked list, so the main objective of your linked list to understand the concept of your linked list, like what is linked list, how many types of linked list, what is node, what is a head pointer, what is your null pointer, how to insert the node in your linked list. And after study about stack and linked list, student should able to how to implement the stack, about the application of your stack, post notation representation and conversion, and to able to traversal of node in a linked list, and to able to implementation of linked list. Okay, and now before implementation the stack and linked list, first I will discuss about linked list and your stack. You know, stack stack is based on your LIFO. LIFO means last in, first out. L for last, I for in, F for first, and O for out. Last in, first out. Stack is based on last in, first out because which item you have to insert it in last mode, that item will remove first. That's why your stack is based on LIFO. For you can take the many examples of your stack like CD box. Okay, you know, in your CD box, because your insertion and deletion from only one end, not for two end, means you will insert the item into stack from one end, and also you will delete the item from the same end. That's why I had told your stack is a in your stack is based on your LIFO, and your in your stack your insertion and deletion are allowed from only one end. Okay, suppose you are having a 5 CD and you want to insert the CD in your CD box. First of all, you will insert the first CD. After that, you will insert second CD. After that, you will insert third CD, fourth CD, and your fifth CD. Means fifth CD is your last CD, which you have to insert it in your CD box. And when you want to delete, suppose your second CD from your CD box, which you have to insert it, before deletion of your second CD, you should remove the fifth CD which you have to insert it in your last mode. That's why your stack is based on your LIFO. Okay. You know, your stack is a your abstract data type with a bounded capacity, and also you can say that it is a simple data structure that allow adding and removing element from only one end in a particular order. In a particular order, I am telling because first of all, you will delete the fifth CD. After that, you will delete the fourth CD. After that, you will delete the third CD. After that, you will delete the second CD. And if you want to directly remove the second CD from the CD box, so that is not possible. For remove the second CD, first of all, you will remove the fifth CD, fourth CD, and the third CD. That's why I had said that in a particular order, means inserting the item in a particular order and you are deleting the item in your particular order. And every time an element is added, it goes to the top of the stack. You know, in your stack, you have to insert it the five CD, and fifth CD is your last CD of your CD box. So your top will point to the fifth location in which you have to insert it the last CD. Okay, and that can be removed is the element that is the top of the stack. And also, if you want to remove the element from the stack, so you will remove the element from only top position, just like a pile of your object. Okay, and after overview of your stack, if we will talk about the linked list, The linked list is also a simple data structure where your elements, your nodes will connected through the each other. Means your first node will connect to the another node, your next node will connect to the another node. And also you can say that a linked list is a linear data structure in which the element are not stored in at continuous memory location. And in your linked list, all elements are linked using a pointer. And what is the node in your linked list? The node is consist from two parts. First part is your data, and second part is your pointer, which point to the next node. And your first node is your head pointer, and your last node will point to the null. Means null is the indication of your end node. When you will traverse the linked list, traverse, visit of each node, traverse the each node. So first of all, you will traverse the first node. After that, you will traverse the second node. After that, you will traverse the third node. After that, you will traverse the fourth node, and you will traverse whole of list of node. Okay. And your first node, I had told you, your first node will point to the head, means your head pointer will point to the first node, and your last node will point to the null. Means null is the identification that you have to traverse the full list. You have to traverse the all nodes of your list. Okay. And you can see in my shared PPT, in this list, I have taken four nodes. First node is your A node, second node is your B node, and third node is your C, and fourth node is your D. And also you can see in this list, your each node have divided in two parts. First part is your data, and second part is your next. Next means which point to the next node. You can see in this linked list, your second part is point to the next node, and the second part, that is your next, will point to the third node, that is your C, and your second part of your third node will point to the D node, and your second part of your pointer of your last node will point to the null. This is your linked list. And here, through this PPT, I am trying for understand the concept of your push and pop operation. You know, push and pop both are operations of your linked list. Push operation, push operations means you will insert the item in your linked list, and pop operation, pop operations means when you will delete the item from the linked list, and both are operations of your stack. You can implement the push operation alone, and also you can implement the pop operation alone. Okay, and here I will implement the stack with your all operations like your push and your pop, and also I will take a one operation is that display. Okay, in this push and pop operation, you know, your push, I have taken the two arrow. One arrow is nearby for your push operation, and the second arrow is nearby for your pop operation. One arrow is coming from outside into stack, and one operation is going from stack to outside. So your coming arrow is the indication you will insert the item into stack, and your going arrow will indicate you will delete the item from the stack. So means your push operation is that when you will insert the item into stack, and your pop operation when you will delete the item from the stack. Okay, and here as per I had told before start the implementation of your stack, we should know about the algorithm of your push operation, because through the algorithm your concept is clear about the stack, your concept is clear how to write the steps in your program. And if you don't know about the algorithm of your stack, and without written the algorithm, if you want to write the program of your stack, if you want to implement the stack, obviously you will face the problem. That's why there is a fundamental truth when you will implement the any technique. So before implementation, algorithm is a must. Before implementation the any program, your algorithm is required, because through the algorithm you should know how to write the steps orderly in your program. That's why I am giving the overview of algorithm of your stack. If we will talk about the algorithm of your push operation, you know your push operation when you will insert the item into stack. If you want to insert the item into your stack, first of all you should know about how that is your stack is full or not. Because your stack is full, so you can't insert the item, and your stack is not full means you can insert the item into your stack. I am taking a simple example. Suppose you are having a room, and your room capacity is for only 30 students, means 30 students can sit in your room. And after taking the seat in your classroom, means your 30 students have already taken a seat in your classroom, and after that suppose your 31 student and 32 student want to enter in your classroom, and want to take the seat in your classroom. That is not possible because your room is already full, because your room capacity for only 30 students, only 30 students can sit in your room. Okay, in the same manner, suppose if you are taking a array, and yeah, suppose if you are taking a stack and you want to and your stack size is your only five student, five elements, and five elements you have to already inserted in your stack rooms, and now you want to insert the six element into your stack. That is not possible because your stack size is your 5. Only you can stack, only you can insert the only 5 elements into your stack. Okay. And now, so first of all, you will check if the stack is full or not. If your stack is full, means you can't insert the item, and if your stack is not full, means you can insert the item. In your first step, check if the stack is full or not, and in your second, if the stack is full, you will print the error of overflow, and you will exit the program. And if the stack is not full, then increment the top. In the third step, you can see a new word is the top. Top will be increment. So top will be increment means if you have to inserted the two item in your stack, so that time point to the your top will point to the second item, means your top will point to the second location. And when you have to inserted the third item into your stack, so your top will be increased. That time your top will be your third position. Okay, so that's why I had told your top will be implemented after insert the item into your stack. Okay, and that is the algorithm for your stack. You can understand about the post operation through this my PPT slide, in which before inserting the your top will point to the D item, me top will point to the fourth location. Here I have started the location from 0 1 2 so that time your before inserting the E element in your stack, your top will point to the third location. And after inserted the E element into your stack, you can see your top will point to the fourth location, means your top have to be incremented by 1 in your post operation. Okay, I hope you have to understood about the post operation through this PPT. And now I am taking the algorithm of your pop operation. In your pop operation, first of all, you will check if your stack is empty or you're not. If your stack is empty, so you will produce the error कि your stack is empty and you can't delete the item from the stack. And if your stack is not empty, so you will delete the item from the stack, you will pop the item from the stack, and that time your top will be decrement by 1. Top will be decrement by 1 because before deleting the item from the stack, suppose your top will point to the third location, and after deleted the third item from the stack, your top will point to the second location. So that time you can say that your top will be decrement. Okay, why 1? You can see, you can understand about the pop operation through this slide. Before delete the E element from the stack, your top will point to the fourth location. Here I have started the location from 0, and after deleted the E item from the stack, your top will point to the third location. Okay, so means you can say that in the pop operation, when you will delete the item from the stack, your top will be decrement. Why 1? And now I am implementing the stack. You know, I am implementing the stack in your C language. You can implement in any other language. There is no any foundation. You only your technique will implement only in this particular language, and here I am implement in your C language. That's why I have taken a header file stdio.h, because your printf and scanf functions are already defined in this header file. And also I have taken a stack of 100 size, and also I have taken choice and top x and I are the other integer type variables. And in this implementation, I will make some functions. I will make a post function. I will make a pop function, and I will make display function. Post function I will make for insert the item into stack, and your pop operation for delete the item from the stack, and your display operation for display the all items which are existing in your stack. You can see in my given slide. And here I have taken a main function, because in each program minimum one functions is a main directory, and if your one function in your program, that is your main function. So here is your main function. I will make the main function, and at your initial stage, top assignment operator is equal to -1. Okay, this is your initial stage. And first of all, I will print the message. Just enter the size of your stack. As per I have taken 100 size, and scanf n means the value of n you will take from the user, and another you will fire a message stack operations using array, and again you will fire another message, because this message you will fire because you will make up many functions. For one function is for push operation, for pop operation, for display operation, and your exit. And here you will take a loop, and here I am taking a do while loop. I think I hope all are known about the syntax of your do while loop, and how to work the do while loop. So in your do while loop, first of all, I have fired a message, enter the choice, because you are having the push function, pop function, and your display function, and your exit. Means you are making four functions. Okay, and scanf choice means you want to take a push operation, or you want to take pop operation, you want to take a display operation, you want to take exit operation. And here I have used the switch case. Your switch case only, in which case where you are having many options. And here choice are push, pop, display, and your print. And after the push operation, you have to use the break keyword. And in your default option, suppose your any case will not match, so that time your default option will execute. Okay, and that's why I have taken do while, and given the choice is not equal to 4, because I have taken the fourth choice. First choice is for post, and second choice is for pop, and third choice is for display, and fourth choice is for exit. And in your post operation, when I will make the post operation, first of all, your top is greater than equal to n minus 1. And if your top is greater than equal to n minus 1, means your stack is overflow, means you can't insert the item into stack. And I have taken this condition in your if else part. If your stack is not overflow, so you can insert the item into stack, and that time your top will be increased by 1. That's why I have written top plus plus. Top plus plus means top equal top assignment operator top plus 1 means you will increment by 1. So that time, and also you that your minus 1 means your stack is empty. If your stack is empty, so your message will be fired, your stack is underflow, you can't delete the item from stack. And if your this condition is not fulfilled, this condition is not true, so your else statement will be execute. And your else statement here, your else statement is the indication your stack is not full and you can delete the item from the stack. If you will delete the item from the stack, so your that time your top will be decreased by 1. That's why I have written top minus minus. Minus minus means top assignment operator top minus 1. And your I have taken your display another function in which I have taken a condition top is greater than equal to 0. So means you will find a message your element in your stack. And for print the all element, for display the all elements in your stack, you will start your loop from the top. And your I is greater than from equal to 0 and I minus, that is your for loop. You know how to implement the for loop, how what is the process of your for loop. And that time your printf your stack I means if your top is equal to 5, so your fifth element will be print. After that, fourth element will be print, third element, second element, and your first element. Okay, and you know how to implement the linked list. You know, linked list. Linked list is the collection of your nodes where your one node will connect it through the another node. And you know your node is to be divided in two parts. Your first part is for data and second part is your pointer. And discussed about the linked list, I am writing the algorithm for display the linked list. When you will display the linked list, as per I had told, your linked list is the collection of your node, and your node is divided into part. First part is your data, second part is your pointer will point to the next node. So in your linked list, you will create the node. And as per I had told, I had already mentioned in this slide, your node is divided. And your node has two attributes: data and your next. Next is your pointer to the next node, and you will create the another class has two attributes: head and tail. Head and tail means head is a point to the means a head to the point to the first node, and your tail will point to the last node. That is your add node will add to the new node into your list, and you will create a new node. And display display will display the all nodes in your linked list. And now I am talking about the implementation of your linked list. Here I am taking the two header files stdi.h and your stdlib.h. you know stdi.h for printf and scanf function, and in your stdi lib is your header file for your library. Means in your lab, from the library you can take the function. If you have to already define mention the stdi lib.s header file, first of all you will make a node. Your node is consists from two part, data and your next. So first of all your head point to the null and your current point to the null, and display the list. And when you will print the list, when you will print the linked list, so first of all you have to take a node pointer type, and that is equal to your head, and your you will find a message, and you will start from the beginning. When you will display the linked list, so first of all you will display the first node. After that you will display the second node. After that you will display the third node, and after that you will display the fourth node. So at your initial level you will start from the beginning. You will start from the beginning. And while your pointer is not equal to null, pointer is not equal to null is the indication you have to visit the all nodes of your linked list. You have to traverse the whole linked list. This is the indication of your ptr null. So that's why I have taken the condition ptr is not equal to null. And if your condition this satisfy, so your data and your pointer will point to the next node, and you will print the null. And when insert link at the first location, so you have to make a function for insert. First of all you will create your link, and when you will insert a node in your linked list, so if you are taking any variable, so obviously your variable will take the space in your memory. Every variable will have the address in your memory, that is the location of your variable. At the same time, in the same time, at the same manner, if you want to insert the node, so first of all you will allocate the memory for a particular node. Okay. And you have to allocate the memory through the malloc function, and your data will be linked, and your point it to the old first node, link next equal to head, and point first to the new first node, head equal to link. And after that, every program have a main function. There is no foundation of functions how many functions you are taken. And this is the fundamental truth. Every program will have the minimum one function, and if your program has the only one function, so that is your main function. And in your main function, and your function will always return a value. And by default your function will always return the integer type value. And if you want to your function will return the other type value,